Hey everyone, in this video we'll be going over pre-calculus, arc, cosine, arcsine, and arctan. So basically just the inverse of trig functions. So in order to follow along with this video, you might want to have a unit circle. And this is one of the basic fundamental uses of the unit circle and a basic topic in pre-calc. So let's look at our first problem. We have arc cosine root 3 over 2. Now, when you see arc cosine, right, so there are a couple of variants for arc, and then whatever trig function. So in this case, for arc cosine, right, you'll be trying to find a coordinate. So you're trying, when you see this, you're trying to find a coordinate, and that coordinate should essentially match up with this. So we should be finding what is cos x is equal to root 3 over 2. So that's essentially what you're doing. But there is a catch. The catch is that the arc makes it so that you can only use a certain portion of the unit circle. And for cosine, you can only use the top portion of the unit circle. You can only use here to here. So though in a normal solving standpoint, you would use cos x equals root 3 over 2, would normally have two solutions. When there's an arc cosine, there's only one solution because you're using only a portion of the unit circle. You're using the top half. And for arcsine, it's the right side, but we'll get into that a little later. But for cosine, arc cosine, or cosine inverse, you're only using the top half of the circle. So when we use just the top half of the circle, we find that the only coordinate that ends up with the only coordinate that actually works for cos x is equal to root 3 over 2 is here at pi over 6. And that coordinate is root 3 over 2 comma 1/2. So normally there's a second coordinate that's on the lower part of the unit circle, but that is not allowed because that's in the no-go region. We're not allowed to go there, at least for arc cosine. And since pi over 6 is the only answer that works, our answer is pi over 6. So it might be a little confusing at first, but we'll go over a couple other problems as well. So let's look at number 21 here. Now in this case, it's inverse cosine. This -1 indicates inverse. But that is essentially the exact same thing as arc cosine. That's no different, at least in this scenario, right? There's no different. So we'll just take what we learned from the previous problem and apply it here. So arc cosine minus root 3 over 2, so negative root 3 over 2, that's essentially just arc cosine. Well, here this is more like actually cos x is equal to minus root 3 over 2, but the second catch is that we can only use the top half of the circle. For arc cosine, we can only use the top half of the circle. So the only coordinate with cos x equals minus root 3 over 2 in the top half of the circle would be 5 pi over 6. So if we let's draw a quick unit circle here. So right over here, we have 5 pi over 6, and the coordinates are minus root 3 over 2, comma 1/2. And now, since we can see from the coordinate that minus root 3 over 2 actually does work for cos x, and it is in the top portion of the circle, then we can confirm that our answer is just 5 pi over 6. And that is our final answer. Now let's look at number 22. Number 22 is arcsine and then negative root 2 over 2. Now, it's the same type of problem, but it is still a little different because instead of arc cosine, we have arc sine. So, in arc cosine, we can only use the top portion of the circle. But in arc sine, we can only, it's a little different because we can only use this right side of the circle. So not the top, we can only use the right side of the circle. These two left side portions are not allowed. You're not allowed to find coordinates in the left side of the unit circle for arc sine, or else it will not work. So that is the rule here. Like arc cosine, which is just the top half, arc sine is just the right half of the unit circle. So with that in mind, we can go ahead and break down this problem like we did the previous two problems. We'll set this into, essentially, sine x is equal to minus root 2 over 2. And remember, you can only set this up as sine x equals, or whatever, as long as you realize that you can only use half of the circle. So once we've set it up this way, the only coordinate or part of the unit circle that actually works is 7 pi over 4. However, there is a catch. So let's just write down for now 7 pi over 4. But that is not our final answer. Because there is one tricky thing that is always a little hard to remember, but for arc sine, only for arc sine, there is a small rule. If you find a coordinate that's in the lower half of the unit circle, so in this area, if you find something there, it is the negative of the top. And what I mean by that is 7 pi over 4, if you look at your unit circle, is the opposite of pi over 4. It's in the same line, it's in the middle, it's the middle line, but it has obviously switched signs for its coordinates. Switch signs, so instead of like a negative, it might have a positive, or vice versa. But instead of writing 7 pi over 4, for arc sine, we are going to write negative pi over 4. That'll be our answer. Now, if you look on your unit circle, it is essentially the opposite. So pi over 4 is the middle line, and 7 pi over 4 is the middle line of the lower half. So 7 pi over 4 is just considered here to be negative pi over 4. That's important to remember. I don't really have a clear explanation for why, but that's just how it is for arcsine. So let's just look at arctan. So here we have arctan times root 3. Now this is very similar to the problems we've been doing, so let's just go ahead and set it up as tan x is equal to root 3. Now for tan, it is the same thing as sine. So in tan, you can only use the right side of the equation. Tan, you can only use the right side of the equation. So it's just like sine. So knowing that, we can set it up as tan x equals root 3. And then from there, we can just solve. So x would be equal to pi over 3. And remember, that is our top half. That there is our top half, so we don't need to write the negative. The only time we would have to write the negative here would be if we got 5 pi over 3. 5 pi over 3 is the opposite of pi over 3. It's like it's on the lower half instead of the upper half. So we would write negative pi over 3. But that would only be if tan x is equal to negative root 3. But here it's positive, so it's just pi over 3. We're fine. It's in the top portion of the circle. So that's how you solve problems like this. So that's all I'll be going over in this video. Next video, we'll be going over this lower section of the worksheet, and essentially it gets a little more complicated in your solving. So we'll be going over that. So be sure to like and subscribe and watch our future videos.